guys, this video is on proportional relationships. Okay, it sounds a lot harder than it really is, so don't worry, okay? But go ahead and open your math notebook and make sure you're taking these notes. Okay, so let's write down some vocab words. So just remember, if I write, you write. So first of all, a proportion. And I spell it wrong all the time, so if I spell it wrong, just ignore me and you spell it right, okay? So what this is a statement that, and remember, just because it says statement doesn't mean we're necessarily using words. We may in some problems, but these could also just be numbers. So a statement that two rates, also called ratios, are equal. Okay, so two examples would be like 6 miles per. Now notice when I say the word per, I make it a fraction. There are times that it means multiply and there's times that it means divide, depending on how they're using this word. You're going to see kind of how it's being used both ways in this example, and we'll kind of make that connection back to multiplication in a little bit. So for now, make it a fraction because we're comparing two amounts, okay? So 6 miles per 2 hours is equivalent to 3 miles per 1 hour. So notice we just reduced this fraction, but we kept our units the same, and these are the same exact rates. And then another version of a proportion is just that 2/4 equals 1/2. So it can be as easy as that. It doesn't have to include the words, but most of the things we're going to focus on will be in a word problem format. Okay, if you need to, pause and finish those notes. I'm going to erase, and we are going to define the word, or the words, the term rate of change. Rate of change. Okay, so this is a rate that describes how one quantity changes in relation to another quantity. Okay, so it sounds way more difficult than it is. Okay, but let's get these very formal notes and definitions in our math notebook so that we can go back and reference them, and then I'll break it down in a way that for sure you're going to understand it. Okay, and then what you need to know, so pause if you need to finish writing these notes. So what you need to know lastly, before I show you some examples, is a proportional relationship. And that's what it's going to be asking you. All the questions you do will say, is it a proportional relationship? Okay? So what this means is that those two quantities I was talking about are changing at a constant rate. Okay, so I'm going to show you an example. So in this example, we're going to have number of days. Now, we're going to be making these graphs. You're going to see them in the math notebook. In the math book, you're going to see them on my examples and everything like that. So a lot of the times, you're going to notice if there is a time involved, days, months, years, minutes, whatever it is, you're going to see that in the top. And by the time you get to 8th grade, we're going to be calling that your X and calling this your Y. Okay, and time will always be in the top if time is a part of the problem. Okay, and that's really important that you understand that. So write that down as a note somewhere. Okay, so number of days, and in this example, we have 1, 2, 3, 4, 5 days. And then at the bottom, we have money earned. Okay, so on day 1, they earned $16. On day 2, $32. On day 3, $48. On day 4, $64. And day 5 is $80. okay? So what we do with a proportional relationship, okay? And I'm going to make it really simple, but then you need to pay attention to the actual word problems, and it'll help make more sense in a real world situation and not just here's the math steps, do them. Okay? So what we do is we're going to figure out how much money we earned per day. Money per day. So notice the first thing I'm going to say is always the bottom, the Y. Okay? And I'm going to divide each amount by the top. So I'm literally going to do 16 divided by 1, 32 divided by 2, 48 divided by 3, and I'm going to do all of those. And for this math, you can definitely use a calculator. So check it if you don't believe me. But if you divide each of these, so 80 divided by 5, 64 divided by 4, you get 16. And that means it's $16 per day. And this is a proportional relationship because everything that you divide gives you the same amount. It's changing by the same. You are getting a consistent $16 per day. It's not that one day you get 16 and the next day you get 17 and the next day you get 14 and we kind of add those up. No, every single day is $16 per day. This is a proportional relationship. Okay? So this number right here, this $16 per day, this is the rate of change. This is the rate of change, okay? And in these problems, you're going to need to know this number, and you need to add a unit to it if there is a real-world example. And this 16 is also called your K, and K stands for rate of change. Please write that, because all of a sudden you're going to see a K in one of the problems and go, what the heck are they talking about? Okay, so that the K is this number that we're looking for. Now, if you start dividing these, and even one of them, which they're going to trick you and they'll put that one at the last, but if even one of them is not the same amount, even if it was 0.74 and the next one's 0.75, then this is not a proportional relationship. Okay? So I'm going to add one more thing to this. So I'm going to erase this part. This is the part we did all the math from. And we're going to focus on this $16 per day. Okay? $16 per day. We are going to write an equation that represents this situation, this proportional relationship. And I know that it sounds tricky, but if you really just stick to this like a pattern, you're going to have the right equation every time. So this is where that word per comes back in as a multiplication problem. Do we know how many days that we're earning money? The answer is no. So as soon as there's something we don't know, we make that X. And if 16 per day, then day is going to be X. And remember, look back at your notes, I made the day the X in the table. Okay? So to represent 16 per day, we would do 16X. And this means 16 times X. And then because it's giving us a total, we're going to say Y equals 16X. This is the equation. This just means any amount of days you want to do this math for, you can plug it in to the X, do 16 times that number, and you'll know your total. And Y can be total. Total. Okay? So the question might ask you two things. It might ask you for the constant rate of change, which is 16, and you can write that as K equals 16. And the second thing that they want from you is an equation. And it's just going to be a Y equals every time because total equals. Take your rate of change and put it in front of X. If your rate of change is a fraction, simplify it and put a fraction in front of X. But this is the equation that explains this. And I'm telling you right now, if you really remember how to make what I call a per amount, which is 16X, Y equals 16X, you are going to be so set up for 8th grade, it's not even funny. Okay, so this is a really, really important lesson to make sure that you understand. All right, so let's look at another example. So in this example, they're going to tell us that the number of pounds and cost. So this one doesn't have a time. So you've got to just kind of know that you're still doing this bottom divided by the top. So 2, 3, and 8, and then they tell us 19, 28.5, and 76. So what we do is we divide 19 divided by 2. We get 9.5. We do 28.5 divided by 3, and I'm saying it in the order you put it in the calculator. We get 9.5, so let's check this last one and make sure they didn't change it on us. 76 divided by 8, we still get 9.5. So here we would say the K, or the constant rate of change, is 9.5, and our equation is y equals 9.5x. All right, so hopefully that makes sense. I want you to do a your turn. So if you need to finish writing, pause. Okay. So I want you to do a your turn, and the your turn is students per adults. So 12 and 1, 36 and 3, 60 and 5. Pause the video, write your K, and write your equation. Okay. When you go to do 1 divided by 12, I know you're going to be like, really? Mrs. Thompson, why didn't you tell me this? You can just leave it as 1 over 12. And if you take 3 over 36, it reduces to 1 over 12. And if you take, 5, so it's the bottom number over the top, divided by 60, and you reduce it, you get 1 over 12. So your K is 1 over 12, and your equation can just be y equals 1/12 with an x after it. Okay? I really want you to pause the video. I want you to do the guided practice, and then as soon as you come back on, I'm going to read you the answers really quickly. Okay, so in the guided practice, number 1 is 45 words per minute, and that's yes. It is a proportional relationship. Number 2, K equals 5, so your equation is y equals 5x. Number 3, K equals 1 over 4, so your equation is y equals 1/4 x. Okay, and you can just write it like you wrote this, 1 over 4x. If you put a 0.25x, that's perfectly fine. It's the same exact value. I want to show you one more thing that you're going to need to do your homework. It's a total side note, but when you see the problem, you'll go, oh, I'm so glad she said that. I just want you to know, when you are multiplying any number by 9/5, it sounds really terrifying, but all you do is you take the number, you multiply by the top, and you divide by the bottom. It is the same, because look, 10 times 9, 90, 1 times 5, 5, and now you got to divide it. So if you just put into your calculator 10 times 9 divided by 5, and you hit equals, you'll get the answer. So literally, you can just do 10 times 9 equals, depending on your calculator, divided by 5, 18. Okay, and that's the same exact as multiplying by 9 over 5. So hopefully you remember that, and it'll help you on a problem you're going to work on. Okay, guys, good luck, and email me if you have any questions. Thank you.